Okay, so we are talking about derivatives in economics. And the main thing that you need to know is that if you are taking business calculus, this is what you're going to look into. So, if we were taking engineering calculus, which is what you're doing right now, it's talking about velocity is the first derivative, acceleration is the second derivative, everything that we've been working on right now. But when you get to business calculus, the economists, they also use calculus. Because it's really, really important. And so they changed some of the wording on there, but the math is still the same. So if you know the engineering calculus, you know the business calculus as well. Instead of calling it a derivative, they call it marginals. So when you're looking at something that we have the cost of producing some kind of unit or whatever it is that it's producing, and it is producing this many units, the marginal cost of the production, that's saying what is the rate of change for the cost depending on how many we produce or how many we don't produce, whatever it is that you're trying to answer. So when it says here, it'll say the cost is C of X. So one of the things that you need to know in business is that the profit, on highlighter mode, is that profit is equal to the revenue. Revenue is the money that you have, and the profit is going to be the revenue if it is no cost. But if there is a cost, we have to subtract it from the money that we have, and therefore the profit is whatever we have left over. Sometimes there is no profit if this number is negative. So when they're talking about the cost of production, that function C of X, they're talking about this cost. There could be something about the revenue. The revenue is money that's coming in. And so it'll say R of X. And then P of X is the profit function. And so here we're talking about how much, at what rate is it costing us to produce so much of whatever. And then depending if we have an equation, like how many workers are working and if they're working at a rate of 5 machines per hour, how much are we producing? Are they producing 5 machines per hour? That's what the derivative will tell us. So we could use it in many different ways on here. And notice how here the math looks exactly the same. Look, the limit is still there. H is still approaching. H is still the same as we talked about before. Here, the derivative, the change in the cost over the change in the units of whatever we're talking about, this is all still the same as we talked about. This is the marginal cost of production, or the derivative of the production of the cost. Notice how the curve is your C, and we have a tangent line tangent to that point, and it's the slope of the tangent line that's going to give you the marginal cost, which again is the derivative. So we are not doing anything else except for changing the name of derivative on there. And we're only going to spend a couple of days here just understanding so that you know that whatever you're doing here, and if you go into business calculus, you still are understanding the material. You just have to know the vocabulary of what they're using. So you could go back and read this if you want to on here, but let's apply a problem. Suppose that the dollar cost of producing X washing machines is this function. So here is our cost function. Now, the first thing that it's asking us is to find the average cost per machine of producing the first 100 washing machines. So when I'm doing this, I am talking about the average. And so we know that the average means the slope of the secant line. If you don't remember that, make sure that you know that. The slope of the secant line. Now, how accurate is that? It's not very accurate, but that's what they're asking us when we say in the average. Okay, so how do I calculate the average cost? So in order for me to find the average cost or the slope of the secant line, I know that I need 2 points. So where am I going to get those 2 points? Well, in order for me to get 2 points here is I need to know what I'm talking about. So it's the first 100 machines. So that means that I am going to start at 0 because it's the first ones all the way to 100. So the first point, if I actually put that in, I am going to calculate C of 0. So C of 0 means that I am going to put in a 0 here and a 0 here, and that means that it's going to cost me, before I make any machines, $2,000. $2,000, that could be anything from materials to employee payment, or I don't know, It could be anything that's costing me $2,000 before I even get one machine made. And then it's the first 100 machines. So we're going to get the information of C of 100. So you put those both in there and you calculate them. I know that this one here is going to be 2,000. And when I put in 100 in here and 100 in here and 100 in there, and I calculated, it ends up being 11,000. So these are my 2 points on there. So now I have 2 points and I want the slope of the secant line. So it's still going to be y2 minus y1 over x2 minus x1, all the slope information from regular algebra. You're going to apply it now. So 11,000 is coming from this point. So that means I have to put 100 down there. That's the x value. We're subtracting them. This is 2,000 coming from one and then the 0 coming from the other. So when you calculate this, it turns out to be $90. So what does that mean? Make sure you write a sentence on there. Every one of these requires a sentence. So the average cost per machine of producing the first 100 machines is $90. So that's what you would write on there. I just don't want to take the time, make the video longer. Okay, so it's saying that the average cost is $90 per machine. Now, we're going to talk about the marginal cost. The marginal cost is the derivative. It's the instantaneous speed. It's the instantaneous cost on there. So we have here that it's marginal. So now we are talking about the derivative. So that means that in this problem, I am going to have to find the derivative. So the derivative of what? The cost. So therefore, it's going to be out of my cost function. So I'm going to do C prime of x is going to be negative 0.2 x plus 100 because the derivative of 2,000 is 0, and that's what we get. So we want to find out the first 100 machines. So we are going to do the 100 in here, and it's going to be negative 0.2, 100 plus 100 on there, and it turns out to be $80. So it actually, after producing, so here it's not at 100, is after. Remember what I said before, it's always after. A rate doesn't happen at the same time. So when you were talking about those problems with the rain falling that we talked about in interpretation of the derivative homework, that means that at 10 a.m. the rain did not fall all at once. Bam, there is 1 inch of rain there. It did not rain 1 inch until 11 o'clock. So it took a whole hour for it to rain. So it didn't happen. So when we are producing 100 machines, it's not when we produce 100 machines, it's after we produce 100 machines. So after producing 100 machines, the next machine will cost $80 to make. So the 100th machine did not cost $80 to make. The machine after it, the 101st machine, is what cost $80 to make. So let's prove that. So we're going to show that the marginal cost when 100 machines are produced is approximately the cost of producing one more washing machine after the first 100 were made by calculating the later cost. So what this is saying here is that if I am going to use just regular algebra, not the derivative, so I could show you that the derivative actually makes sense. Let's say that I have this cost C of x. This is the equation that we have. So if I were to put in C and I put in the 101 machine, so all I do is just go straight into this one here and put 101 here, 101 here, and then calculate it. It actually gives me 11,079.9. So that's what it gives me, the cost for 101 machine. And then we already know how much it costs for one machine. So that we know that that's going to be 11,000 11,000 because we calculated that up here. So at 2000, at 0 was 2,000, at 100 was 11,000. So at 101 machine, this is what it is. At 100, it's 11. And in order for me to know the cost between that is that we're going to take the 11,079.9 subtracted from 11,000, and we end up with 79.90. So it is actually going to cost me, again, what we said, $80. So $80 is what's going to cost the 101 machine. So this is the rate. The rate is always talking not about the 100th machine when you find the derivative, it's talking about the next one because that's the rate at 100. So the rain is falling. That's the example that I always go back into my head to look at when I'm talking about derivatives. The rain is falling at 10 a.m. at 1 inch per hour. At 10 a.m., that's the rate. It did not fall all at once, bam, 1 inch at 10 a.m. It took a whole hour for it to do that. So 1 hour afterwards, that's when we have the full inch of rain. This is saying the same thing. The rate at which it costs at 100 washing machines is $80. So that's how much it's going to cost me to make the 101th washing machine. So that's what all it's saying on there. Okay, so that's it for today. Go ahead and try attempting. This one's talking about revenue. It's still the same thing. It just means that the revenue is the money coming in on there. And so you could be able to do the same thing we did on there. All right, very good.